Okay, let's do a couple of examples of finding the probability within a normal distribution. I'm going to be using the chart for the first few examples, and then I'll be using the calculator for a few examples. And I think it's beneficial to see how both of these work and how they tie together. Now, of course, if you're not planning on using the chart to do your final work, you don't need to follow along with quite as much fervor as you might otherwise. But in any case, the area to the left, so if I want to, I'm using a standard normal chart. So the standard normal curve, again, is when we have a mean of 0 and a standard deviation of 1. This is a particular normal curve. And the nice thing about the standard normal curve is we can use the standard normal chart for it if we have a mean of 0 and a standard deviation of 1. If we had something other than a mean of 0 or a standard deviation of 1, if either of those were different numbers, we'd have to convert it over to look stuff up in that chart. But for our purposes right now, if I wanted to find the area to the left of z equals 1.25, let me pull up the chart. This is the first, this is one page, but you can see all my z values are negative. So I actually want the next page, which is right here. Let's see, I was 1.25, so let's see, 1.2 is right here. 1.25, so that's 1.2, it's this row. Oops, whatever. 1.25, the 5 in the hundredths place is going to be this value right here, 0.8944. So let me go back here. The area to the left is 0.8944. If we're just looking for the area to the left, essentially I'm saying we have, this is our mean roughly right there, and we have not just 1 but 1.25 standard deviations to the right, z equals 1.25. The area to the left underneath the curve is 0.8944. It is the majority of the area. It's a decent majority of the area. If I want to find the area to the left of negative 2.1, so in this case, my mean is right here, 1 standard deviation, 2 standard deviations to the left. Well, let's say that's 2 standard deviations to the left, and this is 2.1 standard deviations. So z equals negative 2.1 is right, we'll call it right here. If I'm finding the area to the left, again, I can use my chart here. Negative 2.10, so negative 2.1 and a 0 in the hundredths place, that's this value right here, 0.0179. Alright, find the area to the right of 1.12, so I'm just kind of drawing a quick sketch here. 1.12, that's z. If I'm trying to find the area to the right, that's that area there. Well, my chart tells me the area to the left, so I can find the area to the left of z equals 1.12. That's 1.12, that's this value right here, 0.8686. And to find the area to the right, I need to use my complement rule, 1 minus 0.8686, which is going to give me 0.1314. So the area to the right of z equals 1.12, there's roughly 13.14% of the area to the right of z equals 1.12. If I want to find the area between two values, then this gets a little bit more complicated, but it's actually not so bad. Actually, let me draw couple of one over the top of the other. So I'm going to figure out, okay, z equals negative 1.02, I'm going to call it right there. And z equals 0.98, I'm just going to say is over here somewhere. Or 0.92, rather. So my chart can tell me a couple of things. I can look up the area to the left of this value. And I can also look up the area to the left of this value. And if you think about it, if I'm trying to find the area between them, well, I have this whole area, which includes not just the area I'm looking for, but also this area, the little tail. Well, this value, if I look up it in the chart, will tell me the area of the tail. So what I'm going to do is I'm going to find the area to the left of 0.92. Let's figure out what value that is. 0.92. Alt-tabbing. The area to the left of 0.92 is right here, 8212. The area to the left of negative 1.02. I can't talk. Negative 1.02 is right here. That's 0.1539. The area between them is going to be 0.8212 minus 0.1539. That was this area. This is the 0.8212 minus this area. The area of the tail, which is 0.1539, will give us the area between them. So we'll do 0.8212 minus 0.1539 to give us 0.6673. So even though if you're doing this on the calculator, you're not going to be looking these values up in the chart, but this sort of a thought process is still very helpful, which is why I think it's a good idea to go through it. So let's go ahead and find these. Let's see how we'd find these on the calculator. And oddly enough, on the calculator, it's actually easiest to do this part D, and then I'm going to work through these backwards. So I'm going to start with part D, which is the easiest one here, finding the probability that we have something between negative 1.02 and 0.92. We're going to use normal CDF. My left bound, so this is the sketch right here, my left bound is negative 1.02. My right bound is 0.92. My mean is 0 and my standard deviation is 1. So I'll enter that into the calculator. Go to normal CDF. We get negative 1.02. 0.92 is the right bound, 0 is the mean, 1 is the standard deviation. Close that up. We get 0.6673. And fortunately, you can see these do match. If we want to find the area to the right of something, the right of a particular value, so for instance 1.12, then, well, this is the region I'm talking about, so that means this 1.12 is actually on the left. It's my lower bound. If you're using the TI-36X Pro, you'll enter that as your lower bound. If you're doing it, I'm doing it in this way just because it's nice to kind of list out everything. But my lower bound is 1.12. My upper bound is infinity, so I'll do 10 to the 99th, or 1e99 is another way to write 10 to the 99th. I don't know, I like to do 10 to the 99th. Oops, I guess it's not displayed like that on the calculator, is it? It's usually like this. But you can do 1e99 as well. If you're on the TI-36X Pro, it probably has that put in there, and you can just leave it. That's your infinity. And then you do 0 and 1. So we'll do normal CDF. 1.12, comma, 10 to the 99th, comma, 0, comma, 1. Hit enter, and we get a probability of approximately 0.1314. And you can see those match up. All right. The area to the left of negative 2.1. Negative 2.1, we're finding the area to the left, which means negative 2.1 is the right bound, or it's the upper bound if we're going to enter it into our calculator. So we'll do normal CDF. Negative 10 to the 99th, or negative 1e99 if your calculator is doing it that way, or if you want to enter it manually that way. If you're doing it on the TI-83 or the graphing calculators, you can enter it that way as well. Your capital E, so I'll do negative 1. Your capital E, it's actually, I don't know why it's listed twice here. It has the, see it's in yellow. That might be a little hard for you to see, but it's right here, right above the comma. it's EE. So if I press the second key and then that button, you can see it puts a capital E in there. So 1E99. Let's see, my right bound is -2.1, my mean is 0, my standard deviation is 1. We'll do plenty of examples with other means and standard deviations, but you know, we're just kind of dealing just with the standard normal curve right now. Oops. Mean of 0, standard deviation of 1. And enter, I get 0.0179. Let's compare that to what we got before, 0.0179 right there. And then lastly, the area to the left of z equals 1.25. This is pretty much the exact same as what we just did. This is going to be normal CDF. -10 to the 99th. What was it? 1.0, no, 1.25. 0.1. Entering that into the calculator. Let's see. 1.25. We get 0.8944 rather. Which again matches what we would have gotten if we'd done the chart. So on these examples, you can see we get exactly the same values as if we would be looking these values up in the chart. On your calculator, it is actually a little bit more accurate. You can see I do have more accuracy on here. A couple of these, this 8944, it's actually, you know, we rounded up to get to that 8944. It's actually 89435. This is the more accurate version of the two numbers. Not that you really need to care about being that precise. The chart is accurate enough for our purposes in this class. So if you're using the chart, you'll be fine.